Hello everyone, here's a question based on hydrogen emission spectrum. If the wavelength of the first line of the Paschen series of hydrogen atom is 720 nanometer, then the wavelength of the second line of this series is how much? We have to find out the nearest integer. This question may appear straightforward, but it is conceptually misleading and deceitful, which I would explain it to you towards the end. Let us first find out the correct answer for this question. Let's say we have several stationary states for the hydrogen atom. We know that when n equal to 1, that we call it as Lyman series, n equal to 2 is Balmer series, n equal to 3 is Paschen series, isn't it? So this means if an electron that has gone to the excited electronic state comes back to the third orbit or second excited electronic state, then we call that as a Paschen series. Here we need to worry about the first line and second line. So this means if an electron that is there at n equal to 4 comes back to n equal to 3, that is the first line, and then the second line is an electron that is there at n equal to 5 comes back to n equal to 3, then that is the second line. So let's say we have lambda here. Because the energy gap is low, this will be having the highest value of lambda, and for the second line, since the energy is increasing, the wavelength has to decrease. So therefore our final answer is definitely going to be less than 720 nanometers. And the equation that we have to use is Hc divided by lambda is equal to minus Rydberg constant times z square times 1 by n2 square minus 1 by n1 square. n2 is always greater than n1. If we are using this equation, let's say if we are writing it as 1 by n1 square minus 1 by n2 square, make sure to change the sign. Using any equation is okay, but the sign convention has to be perfect. I personally prefer to use this equation because it is a emission spectrum, energy is released, so that's why I prefer to use this equation. Anyways, so we are going to write two equations. One equation is Hc divided by 720 is equal to minus Rydberg constant times z square is 1 because value of z itself is 1 for the hydrogen atom. So therefore times 1 by n2 value is 4. So therefore 1 by 16 minus n1 value is 3. So therefore 1 by 9. And then the second equation is Hc by lambda 2 is equal to minus Rydberg constant times 1 by 25 minus 1 by 9. Now we have to find out the value of lambda 2. So therefore let's divide equation 1 by equation 2. If we do that, then Hc divided by 720 times lambda 2 divided by Hc. Rydberg constant is also common, so we can cancel that. Hc is common, therefore we can also cancel it, is equal to, I am sending the minus sign inside, so therefore 1 by 9 minus 1 by 16 divided by 1 by 9 minus 1 by 25, and this will be equal to 16 minus 9, 7, 9 times 16, 144 divided by 25 minus 9, 16 divided by 9 times 25, 225. So therefore lambda 2 divided by 720 is equal to 7 by 144 times 225 divided by 16. 5 times 144 is 720. So 5 times 7 is 35. So therefore lambda 2 is equal to 35 times 225 divided by 16. 225 times 35 will be 5 times 5, 25, remaining 2. 5 times 2, 10, plus 2, 12, remaining 1. 5 times 2, 10 plus 1, 11. 3 times 5, 15, remaining 1. 3 times 2, 6, plus 1, 7, and then 3 times 2, 6. So if we sum it up, then 5, 5 plus 2, 7, 7 plus 1, 8, 6 plus 1, 7. 7875 divided by 16. So let's do 7875 divided by 16. 4 times 16 would be 64, remaining 14, 7, 5, and then 9 times 16 would be 144, remaining 35, 2 times 16, 32, remaining 3, we can't divide, so raise it to the decimal, and then 1 times 16 would be 16, remaining we will have 14, we can't divide, so raise it to the decimal once again. If we do it 8 times, then it would be 128, remaining 12. So we will keep it to 2 digits because we have to find out the nearest integer. So this is the nearest integer. So therefore, lambda 2 is equal to 492 nanometer. 492 nanometer is the correct answer. Now, here is the problem. 492 nanometer is actually in the visible region. We know that Paschen series falls in the infrared region, isn't it? But now because of the way the initial wavelength is set, it is almost looks like Paschen series and Balmer series are getting mixed up here. In reality, the actual bracket series range is 4051 nanometer to 1458 nanometer, and then for Paschen series it is 1875 nanometer to 820 nanometer, and then for Balmer series it is 656.3 nanometer to 364.6 nanometer. In reality, the shortest and the second shortest wavelength of bracket series get mixed with the Paschen series. This is something well known in the literature. However, here, because the initial wavelength is set at 720 nanometer, it appears as if like Paschen series and Balmer series are getting mixed up. Basically 492 nanometer means we are in the visible region, isn't it? Because visible region is, you might hear two things. One is 380 to 750 nanometer, or sometimes they would also mention it as 400 nanometer to 700 nanometer. But 492 is definitely in the visible range. So that's the reason I said this question is conceptually misleading. In the exam hall, you have to quickly come to the conclusion that they are tricking you here. Of course, one would defend for questions like this, saying that the if condition was there, but still this is conceptually misleading. The best thing to do when you come across questions like this is to cross check your math part and move on to the next question instead of overthinking.